Hello. So this is the energy recapture device. What this does is, say you have a light bulb or some other load, you would have that running as normal, but in that same line you would have this other circuit connected to be able to recapture the energy as it flowed through. Now what we'll do is we'll turn it on. It's pretty bright, we can turn it down a little bit. So it's running, and we're about 33 watts. 34. Okay. You can turn it up all the way, and you get about 205 watts. Now, it's pretty bright. So we're getting, let's see, 220. Alright, let's go up. Okay. Yeah, about 250, 275, 296, about 307. $351, $368, $372, $380, $393. It's almost 400 degrees there. Running at 200 watts. Plus, additionally, we're recapturing the energy as it flows through. Oh, okay. So we have this 24 volt DC motor, and we can discharge this capacitor, which is collecting this electrostatic energy. You can hear the sound changes. So as you're running your appliances, you could actually be recapturing the energy. Ooh, there's a lot of the energy there. So, alright, let's turn that off. And just wanted to show how that can be done. And yes, you have additional light here from our plasma discharge tube, but we have our 200 watts light bulb. This is a 300 watt light bulb, so you be the judge. Was that 200 watts, 400 degrees Fahrenheit? So yeah, we're getting the work from the light bulb here, and additionally through electrostatics, which is just a reaction off of the line. There's no ground for any of this to go into. It's simply electrostatics being transformed into watts to be used on a regular DC load, or for anything. It's stored energy. So while you're running your load, your appliance or whatever, you can have this with a bank of capacitors that then go and charge your battery bank for your house. And that way you're recycling the energy. Because this is just a switching, it's just a reaction that happens from the energy flowing through the coil there. It's not induction. There's not really any energy used up. It just is all electrostatic reactive power, which is then transformed into watts with this capacitor, and then can be discharged into a load. And it's about, it could be up to 100 volts at about half amp. About sometimes I discharge at about 50 volts to get that at about half amp to run the motor. But it'll just keep charging and charging, as much as it can charge. It doesn't ever destroy those capacitors. You can even put a smaller one on it and discharge it quicker if you wanted to try to self-loop the system, which I haven't got to yet. But for now, this is definitely something that could save you on your power bill. So, anywho, there's that. Contact me if you want to know more about it. Okay, thanks.